Alright, Algebra 2, we're in Unit 9, Lesson 9, last lesson of the unit, and we're going to just do some more solving log equations with a few extra steps in there. A few little trickery pieces to watch out for. Hang on. So, as it says right here, you know that if two log expressions with the same bases are equal, then the expressions inside the log itself are equal. So we can use a wider variety without having to go through the whole step-up process all the time. So it says basically to solve these, take a look, I've got the log of x squared is equal to the log of 49. So all you have to do right away is say that, hey, x squared equals 49. And then what do? Take the square root of both sides, plus or minus. And so x is equal to plus or minus 7. So you got two answers, x equals 7, and you got x equals negative 7. Of which in this case, if I put a 7 in there and I square it, okay, right inside here, it's still going to be positive, and if I put a negative 7 in and I square it, it's going to be positive. So, both are valid solutions. So, x equals 7 and x equals negative 7. Both work. We plug right back in. Alright, next. So, next one, you've got the log of this plus the log of this equals the log of the other side. So you guys know that that's the log of the x plus 1 times x minus 2 equaling log of 7x minus 17. Okay, they're both the same log base 10 since there's no base written. So it's real easy. It's just x plus 1 times x minus 2 equaling 7x minus 17. And you go through your box and or FOIL or just double distribute, and you will get x squared. And that's going to be minus an x minus 2 equals 7x minus 17. The x squared is not going anywhere. Therefore, I would do a minus 7x, then a plus 17, and you will get an x squared minus 8x plus 15 equals 0. Factor away. So if I factor it, I get x and x. 15 is 3 and 5, so minus 3 minus 5 will give me a positive 15, and they add up to negative 8. T-split it, and you get your answers of 3 and 5. And if I go check it with the original here, 3 or 5 gets us still positive, 3 or 5 is still positive. And 3 is the smaller one, so that's 21 minus that. That's still positive. So both are valid solutions. Both good answers, okay? Why don't you try the next one right here. Try C for a second. Pause the video, and we'll come back and take a look at it. Alright, so if you check what we did here, basically just set the x squared minus or plus 1 set equal to this. I distributed it on both here, got an x squared minus 2x. And then since there's x squares on both sides, you just move one to the other side. They both fall out, both cancel. So I'm left with 1 equals negative 2x, divide by a negative 2, and your answer is negative 1/2. So then, if you go take a look at this up here, if I put a negative 1/2 in here and I square it, I get a positive 1/4 on the 1. That's positive. That's bigger than 0. A negative 1/2 times a negative 1/2 in here is a positive 1/4. And a negative 1/2 times a negative 2 is going to be a positive 1. So that's greater than 0. So, bottom line, valid answer. We're valid. Good answer. All right. Let's take a look at the next. Alright, so same thing on this one. What can we do first? Combine them down to a single log term. You cannot just set them equal right now the way it is. So it's the log of an x plus 4, since it's adding, times an x minus 1. And that equals a log of 3x Now I've got a log set equal to log with nothing else. So x plus 4, we can pull out the insides, times an x minus 1 is equal to 3x. So go ahead and multiply. You will get x squared plus 3x and minus 4 equals 3x. Move the 3x to the other side since the x squared is not going anywhere. And you will get an x squared, and the x in the middle fall out. Minus 4 equals 0. Now you can move the 4 to the other side, or if you recognize it, it stops. Difference of two perfect squares, so x plus 2, x minus 2 when you have difference of two perfect squares. And tee it up. It's up to you. Or you can move the 4 to the other side and take the square root of both sides. Either way, I get a negative 2. And I get an x equals positive 2 when I move the 2 to the other side. That's what you're doing on each case. Set them both equal to 0 and do that. All right. Negative 2, unfortunately, will not work up in this one, will it? That will give me a negative 3. Positive 2 will. 2 minus 1, 2 plus 4 over here works, and 2 times 6. So valid here. There's our answer. This one here is extraneous. Okay. Move on to another. Subtraction, so you should recognize what does subtraction mean. Well, we're going to take the log of them, and it's going to be the x squared minus x. And yes, subtraction means divide by the x minus 2. And that whole thing will equal the log of x minus 3. Okay, logs are the same on both sides here once again. So just take the x squared minus x over the x minus 2. And that's equal to the x minus 3. And I'm seeing a proportion there, so I put it over 1, and I'm going to cross multiply. So 1 times x squared minus x is x squared minus x. And the other side, you're going to have to do the x minus 2 times the x minus 3. So left side stays the same. Right side becomes x squared minus 5x plus a 6. X squared, same on both sides. I'm actually going to bring the x squared over. I'm not going to bring both over. You can. I see something that's going to happen here, though. X squareds cancel on both sides now. So you're left with negative x squared equals negative 5x plus 6. So since the x squared fell out, I know I want to get the x's all on one side. Add 5x over. I think we'll bring that up over here. So you get a 4x equals 6. Divide by 4, divide by 4, and there's your answer. X is a 3/2 answer. Check it out. Okay, if I take 3/2 and I square it, and then I subtract 3/2 and that, we're okay. And 3/2 minus 2 is not okay. And a 3/2 minus 3 is not okay. Therefore, this is extraneous. And guess what? Start this baby up. No valid solution. Possibility. You've seen it before last year. You've seen it in 9th grade. No valid solution here on this baby, all right? Doesn't work in all the pieces. Okay, that's why we check. Moving on. You want to have some real fun, pause the video and try this one on your own. I'm not going to make you, but you can. Alright, so I got 3 that be added here, so you know the deal. Keep the log, and it's going to be x times an x minus 1 times an x plus 1. All equals 3 times log of x. Okay? Or you can rewrite that as, on the right side, log of x cubed, which you might want to in a minute. So I got to multiply these here. Basically, this is going to be x times what's going to turn out to be when I do these two here is x squared, and I'm going to have 1x and a minus 1x are going to cancel, minus 1. So this side is going to be the log of And in this case, it's going to be x times that. That's x cubed minus x. So if I set this up, got logs on the same side, are the same, base 10. X cubed minus x equals x cubed. If I move an x cubed to the other side, move an x cubed over, you will notice, bingo, gone on both. So I get negative x equals 0, divide by a negative 1, and x turns out to be 0. Okay, so 0 is my answer, but remember, we got to be greater than 0. And if I put 0 in here, that's not greater than 0. That makes it negative. That's okay. That is not 0. So, once again, what do we say? No valid solution. Okay, bottom line is you only have extraneous answers. No valid solution. Alright. Due to the length of this video, and this is the hardest problem, I suggest you pause the video and you can take a look at what I did, but I will explain it in class tomorrow and go through all the steps. It brings back some memories, but I do not have enough time to do it. So pause the video, give this one a try. I'll give you a quick hint clue. Bring this thing over to the other side so that you can get it all on one side. But see my steps and see if you can figure out what I did, and we'll talk in class tomorrow. Don't forget the last page with the summary. I'm going to pause real quick and go there. Alright, so this is our summary page. Brings up a lot of important rules about when to do things. They're the same on both sides, etc. When to subtract, when to add, all that good stuff. So